Okay, so let's get back to the physics that we were doing now, which is it's 10:45. I've got about 10 minutes. So the situation that we are looking at over here, uh, so you have a meter scale asymmetrically balanced, right? And it's balanced in such a way that um, there is no object on the other side, but um, there is equilibrium, static equilibrium. Okay, so the question is that how come there is static equilibrium? Tanisha wants to know about the cos theta part. So Tanisha, I suggest that I'll put up the video, right? So you have a look at the video carefully again. I did make a mistake with putting the angle in the wrong side and then realized a little later and I shifted it. So that part might be a little bit messy, but then it's available for you to see. So you can watch it a few times and see if you can understand. Okay. Yeah, Janu, sound is bad. Is it better now? Because there's nothing much I can do actually right now. Has the sound improved? Okay. Vita says at least that the sound is improved. Neeraj says it's fine. Rahul's saying it's good on my side. Janu is also saying it's improved. Okay, fine. So maybe there isn't enough time to get to the solution in this, but certainly we will be able to work on the idea. Okay, so I'm suggesting the problem right now. So from what we have done so far, we are able to see that for the equilibrium to be there, the clockwise moments, which is this, right? The clockwise moments should be equal to the anti-clockwise moments. Okay, and we can see the anti-clockwise moments are fairly straightforward. There will be this mg, right? And the distance between the line of action of the mg and the axis of rotation, which happens to be there, but that shows the distance between the two. So the anticlockwise moments are straightforward enough. It is mg multiplied by that distance d, perpendicular distance d. If you want to use yeah, okay, that's fine. I was thinking if you use the vector argument, but then uh, the theta is 90 degrees, so therefore it will be 1. So it's just mg multiplied by d, no issues there. The question is, what is the clockwise moments over there? Obviously, the system is in balance, but you can't see that there is any clockwise moment that is there at that time. Akshay, yes, if you should say it's equal and opposite, but the magnitudes is what we are comparing over here. Okay, so we can say that they have to be equal, right? So therefore, the question comes now: where is the clockwise moments there? What is causing the clockwise moment? In other words, what is the force and what is the distance? Both are at question. So how do we answer this point? So what are the suggestions? So the suggestion is Ratul is suggesting that the weight of the scale is on the clockwise side. And how can you say that? The weight of the scale, meaning the sum total of all the mass elements of the scale multiplied by its gravitational attraction. Is that the weight of the scale? And you're saying yes. But isn't part of the scale, that means some mass elements on this side. Ratul and Janvi and also Set. The three of you were sitting in that blitzkrieg, right? So you see, even though you felt you didn't get anything out of the blitzkrieg, is something you remembered. In fact, all three of you seem to remember it. Counterintuitive challenges. Yeah. Okay. So let's humor me a little bit in this. Okay. So let's assume, let's pretend like we didn't know about this, right? Which is often what I have to do. So I'm saying that, well, what we can do is we can say that, well, the weight of the scale on this side is more than the weight of the scale on this side, right? And therefore, the weight on this side is what is balancing the weight on this side plus the weight of the stone. But then again, we end up on the same problem, right? Because if the weight on this side is equal to the weight on this side, then if you shift the stone, there shouldn't be any problem. But of course, there's going to be a problem. If you shift the stone out, the anti-clockwise moments will increase and there will be anti-clockwise rotation. If you shift the stone inwards, then the clockwise moments would increase and there will be a rotation in that direction, right? So that means the weight on this side and the weight on that side cannot be used as the argument. So what can be the force that is acting on that side, and over what distance does that force act to create a torque? So this is the question that we need to tackle. Vikram is suggesting force times distance on the left side is equal to the total distance on the right side. Yeah, but if you take that, on this side you have a torque, right? Because you're saying force multiplied by the distance. But on the right side, you're not giving any force. You're just saying B. So where is the force? You can't compare apples and oranges. It has to be torque to torque. So you're talking about torque on this side, but you're not giving me any torque on the other side. You're just telling me the distance, right? So you have to give me torque. Yeah, the force of gravity. So sort of the answer is kind of like comes out non-intuitively, and it helps us develop the idea of the concept of what is the center of gravity of an object. Okay, so we don't have time to go into that at the moment, and the class 9 maths class is going to begin, so I need to give up the classroom. That concept we will discuss tomorrow instead of uh, Thursday. Okay, so I just want to say that on Thursday I have a seminar to attend in the morning, and I will not be able to take the class on Thursday. My class tomorrow happens to be free because I have taken a break from class 10 physics, and so I will be coming online tomorrow morning at the same time. I will send you an email about this also, and we will take up the concept at that time. Janu, what's your question? Of what? Okay, you got it. Okay, okay. All right. So I hope that part is clear. The development of the concept of this idea, how to solve this problem, and why it leads us to the idea of the center of mass of an object. We will pick it up tomorrow. Tomorrow, that is Wednesday, not on Thursday. Yeah, Thursday we will not have a class, and we will have our class on Friday. Okay, so I'll send an email about that. Reading session, I'll send you. Sumedh wants to know about the reading session, so I'll send you an email about the reading session. I actually want to know how many of you are interested, so I'll send you a Google form about that, which should also happen by today evening, and also information on which book to borrow and so on. So then we can meet about that. All right. So is that clear now? Have I answered everybody's questions? Anything else that needs to be clarified? So repeating again, we have a class tomorrow, not on Thursday. Friday class will be as normal. Uh, Book reading session, I will send you an form, Google form to fill on that. and I will send you an email about this change in plan as well. So I will meet you guys again tomorrow morning at 10:10, and we will discuss and develop this concept further. All right then, bye everybody.